So changing concentrations will cause an equilibrium to shift in response. Changing volumes when you have gases will also cause a change. Because when you change the volume of a gas, you are in essence changing its concentration. So if you decrease the volume of a gas, imagine a gas in a box, right? And the sides are movable and you squeeze the sides in. The amount of gas is the same, but now you've decreased the volume. It's more concentrated, right? So then the reaction is going to want to shift in a way to undo that. If we increase the volume of a gas, that's like decreasing the concentration. If we lower the number of moles of gas, that's going to lower the pressure, right? So think again of a box of gas, and if you remove some of the gas molecules, that's going to lower the pressure. So a system can relieve a pressure change by changing the moles of gas. So in this example here, nitrogen reacting with 3 hydrogen molecules to form 2 molecules of ammonia gas. On the left side of this equilibrium, we have 4 moles of gas. On the right side, we only have 2 moles of gas. So if we push down on this piston and decrease the volume, that's going to increase the pressure. The system wants to counteract that, fight against it, lower the pressure. On this side, there's 4 moles of gas. On that side, there's 2 moles. If the reaction shifts to the right, it'll have fewer particles of gas and it can reduce the pressure. Does that make sense? Nobody's nodding. It's okay. The opposite, if we increase the volume, we pull the plunger up, that decreases the pressure. Well, it's not happy with that either. It just wants to be where it was. Don't mess with me. So you increase the volume, that decreases the pressure, and the reaction is like, what can I do to get that pressure back? So it's going to shift to the left where there are more moles of gas particles. So at equilibrium, if you decrease the volume, it will cause the reaction to shift to the side that has fewer moles of gas. If you increase the volume, it causes to shift in the direction that has more moles of gas. If you have equal moles of gas on each side, then changing the pressure is not going to do anything because the reaction can't fix that if the number of moles of gas are the same. See, the thing about gases is that it's the number of gas particles, not what they are, not how big they are. It's just how many are there. So let's look at this reaction. Here we have gases, SO2, O2, and SO3. So if we decrease the volume of the mixture, what does that do to the gas pressure? We're making the volume smaller. Think of a balloon. How do you get it smaller? You put pressure on it, right? You squeeze it. That increases the pressure. So the reaction, this equilibrium, wants to shift to reduce the pressure. Which side has fewer gas molecules? The left or the right? The right. This side has 2 gas molecules. This side has 3. 1 oxygen and 2 SO2. So when it goes in the forward reaction, it reduces the number of particles. So we decrease the volume, and that causes it to shift to the direction that has fewer particles of gases. If we increase the volume, that decreases the pressure. The system tries to replace the pressure by making more particles, so it'll shift to the left. Does that make sense? Kind of. Yeah, well, I got half a chance of remembering that on Thursday.